Welcome to this explainer, the ultimate cosmological scorecard, auditing the universe. Today, we are conducting a high-stakes audit of the cosmos. We're putting modern cosmology's broken models right on the chopping block, because right now, astrophysics is facing a pretty severe crisis of confidence.
Physics is currently fitting data, not understanding it. Let's look at the ultimate cosmological scorecard. We are framing the exact problem today. The standard theories we've relied on for decades, well, they've strayed incredibly far from first principles. When our telescope observations don't match our math, we've fallen into this habit of just inventing invisible variables to balance the equations, rather than fundamentally rethinking the physics.
7. That is the massive number of catastrophic astrophysical crises currently breaking the standard model of the universe as we speak. We're talking about massive anomalies here. Everything from quote-unquote impossible early galaxies spotted by the James Webb Space Telescope to a glaring, irreconcilable disagreement in how fast the universe is actually expanding.
Let's look at our current reigning champion, the Standard Model, often called ΛCDM. When subjected to this rigorous audit against those 7 crises, it severely fails 5 out of the 7 major tests. It's an incredible framework for tracing cosmic history back to the early universe, absolutely. But it is buckling under the weight of new, high-precision telescope data. So you might be wondering, how does the Standard Model even survive right now? Mostly by heavily relying on invisible patches, dark matter, dark energy, and inflation. The framework literally only works if we assume that 95% of the entire universe is made up of completely unobservable phantom entities. Despite decades of searching in massive particle colliders and deep underground vats, the actual dark matter particle has simply never been found.
It's a really stark contrast we're looking at. On one side, we have the increasingly convoluted gastrophysics and messy theoretical add-ons of the Standard Model. On the other side, we have the elegant, fundamental, first-principle laws that scientists are desperately searching for. We all aspire to have a fundamental theory of the cosmos that doesn't require us to inject invisible, phenomenological add-ons just to make the math work out.
Okay, let's dive into the alternatives. The most famous alternative to dark matter is modified gravity, specifically models like MOND or its relativistic cousin TVS. These theories try to solve things like the weird, flat rotation of galaxies without invoking unseen dark matter. They do this by basically tweaking how gravity behaves at extremely low accelerations.
But when you actually run the numbers across different metrics, modified gravity falls dangerously short. It literally plummets when we look at galaxy cluster dynamics, like the famous bullet cluster, and it totally struggles with precision solar system tests. And honestly, to fix these cosmological shortfalls, these theories often just end up adding endless tunable parameters. So we're essentially just trading one set of invisible patches for a brand new set of mathematical patches.
And that brings us to a radical new challenger, the Integrated Toroidal-Syntropic Model, or ITSM. This is a paradigm shift. It's a framework built not to compete with the establishment's patches, but to complete what they left unfinished. It takes a totally different path, treating the universe as an open thermodynamic manifold.
The core shift with the ITSM is absolutely profound. It discards invisible particles entirely. Let that sink in. Instead, it defines the cosmic vacuum itself as a superfluid plenum. Think of empty space not as a dead void, but as an active, structural, thermodynamic medium. It's like a supercooled, frictionless fluid, where everything moves together as a single quantum entity, governed by a strict donut-shaped or toroidal geometry.
What's truly revolutionary here is how the ITSM systematically replaces both dark matter and dark energy with just 3 fundamental invariant variables. That is it, just 3. Baryonic mass, which is simply the normal everyday matter we can see and touch, the Hubble Flow, representing the cosmic expansion rate, and toroidal geometry, which is the actual topological shape of the vacuum.
Pure geometry, 0 free parameters. We are trading arbitrary phenomenological add-ons and constant fine-tuning for pure exact universe geometry. There's 0 free parameters here. There's no curve fitting being done in a lab to make the model match the telescope data. It is a locked geometric consequence.
For 40 long years, modified gravity models relied on an empirical, totally unexplained gravitational threshold called A sub 0 just to explain why galaxies rotate the way they do. Well, the ITSM resolves this 40-year mystery natively. It derives this exact acceleration scale directly from first principles. The math actually proves this threshold isn't arbitrary at all. It's a locked geometric result of the speed of light, the Hubble constant, and the fundamental shape of a torus.
Auditing the 7 crises with ITSM. Let's see how this new framework actually holds up under pressure. Let's subject it to the exact same 7 cosmological anomalies that completely broke the standard model.
First up, galactic rotation. The ITSM perfectly recovers the acceleration data across 165 high-fidelity galaxies using 0 free physical parameters. It essentially shows that the flattening of galactic rotation is just a torsional drag effect in the superfluid vacuum. Second, the bullet cluster. The ITSM organically separates X-ray gas from lensing maps through fluid dynamic phase space decoupling. In plain English, the gas stalls out in the plenum like it's hitting a headwind, while the denser stellar cores pierce right through. No collisionless dark matter required.
Third, those impossible early galaxies found by the JWST. The ITSM's topology provides pre-existing vortex cores in the vacuum that act as necessary scaffolding, which allows mature galactic disks to assemble incredibly early in the universe. Fourth, the infamous Hubble tension. The ITSM mathematically proves that the glaring disagreement between our local and early universe expansion rates is simply an 8.3% geometric projection variance. It happens naturally when you're looking through a toroidal space.
And rounding out the list, number 5, the latest DESI data showing evolving dark energy. ITSM natively mimics this through a syntropic volumetric decay, totally eliminating the need for hypothetical scalar fields. Number 6, it preserves the early universe cosmic microwave background peaks and naturally accounts for topological anomalies. And finally, number 7, it makes a strict, falsifiable prediction for the NANOGrav background by identifying an exact Lorentzian acoustic resonance in the vacuum.
So what does the scorecard look like now? Let's just pause for a second and take a breath. We've run the absolute gauntlet. We've taken the 7 most catastrophic observational tensions in all of astrophysics, stripped away the 95% invisible universe patch, and applied a strict topological fluid dynamic framework.
ITSM achieves a perfect 7 out of 7 resolution natively. Here's the ultimate scorecard. A complete, parameter-free, geometric resolution to all 7 massive cosmological crises. Every single prediction is a locked geometric consequence, effortlessly checking off every single box where standard and modified models either require undetectable entities or just fail entirely.
No invisible dark matter, no phantom dark energy, just 3 fundamental variables and 0 free parameters. The scorecard is locked. It really forces us to ask an uncomfortable but necessary question. Are we finally ready to stop fitting data with invisible ghosts and start understanding the profound, pure geometry of the universe?